background to the work is we've got over 360 lines of jackfruit, and they each behave slightly differently. So one of the problems we're coming up against is that no one line is working exactly like the others in terms of how they are propagated. We've moved towards the aeroponics. This is going to allow us to screen the lines initially and see how they respond to just the chemicals. So what we've got here is two different plant hormones. So one's IBA and one's IBA plus NAA. And this system, unlike a soil system, we can assess the growth of the roots in. So the reservoir is filled with water and hormone only, no nutrients at all. And you can see these little white bumps. That's actually root initiation, so that's the root starting to push. This system will allow us to screen each of the important lines really quickly and see which ones respond to which hormones and adapt our strategy for the most important lines. They get fed through, so the water sprays out of these constantly, 24/7, and it doesn't, so the stems sit above the water, so all they get is this mist of hormone and water. So we remove from the equation then the effect of the soil, so which potting media, the drainage, all of those sorts of questions, whether you're adding fertiliser to your soil or whether it's sand, which is completely free of nutrition, which means that we're reducing our variables. Once we've worked out what hormones, how long, those sorts of questions, which lines are easily propagated, we're going to do some temperature trials inside in a special incubator, which allows us to control light and humidity. And then we'll put this system in there, and then we'll look at what the temperature range for root initiation is. So we're going to drill down basically into the physiology of the plant. So there's going to be a range where if it's too hot or if it's too cold, you won't be able to get roots to grow, no matter what you do. There's going to be a range of plants where this much hormone will work, but another one, this type of hormone might work. And the other thing we're finding is we're tissue culturing some plants, and we've found that different lines have different concentrations of phenolics, so different plant chemicals, plant chemistry for different lines, and these phenolics make it hard to tissue culture. So we're going to cross-reference those varieties that have the higher levels of phenolics with the ones that are harder to grow in the aeroponics system. The other thing we've found is that some of these trees have higher disease burdens, so they look fine, and then we put them in the aeroponics system and they're dead within 2 days, whereas these ones are 2 or 3 weeks old and they're still going. So we're able to go through and weed out the ones that are just not going to suit the system, and then start working within that system to drill down, as I said, into temperature levels, hormone types. Do we need 2 hormones, 1 hormone? What concentration of hormones do we need? Those sorts of things. The other beauty of this system is because we're adding the hormone into the water, it's getting sprayed and resprayed onto that cutting, whereas in the potting system, you dip it into the hormone, so it might be a gel hormone or it might be a powdered hormone, and then you put it into the pot, and then you sort of hope that when you're planting it in there, you're not scraping off the hormone and it's not getting washed off by the irrigation. So in that respect, this is getting exposed to far more of those natural hormones. So we're hoping that it might be more effective.